Good morning to all. Can we see without light? And can we hear in space? Well, the answer lies here. So in today's class, we are going to discuss about the light and sound, which is the magic of the nature's waves. The first is sound. So the definition of the sound is the form of a mechanical wave and that is produced by the vibrating of the nearby molecules. And the nature of the sound wave is longitudinal. Now, mechanical means which requires a medium. So here, sound requires a medium, and that's why it's a mechanical wave. And longitudinal, the difference between longitudinal and transverse wave is longitudinal wave means they are parallel to the direction of the wave propagation, and transverse they are perpendicular to the direction of the wave's propagation. So here, sound is a longitudinal wave. So these are the key properties of sound. The first one is speed of sound. So the sound travels faster in solid medium than in liquid and in air. So the sound it does not travel through vacuum. So the reason is since sounds requires a medium, in vacuum there is no medium, and that's why the sound cannot travel there. Now why the sound travel faster in solid medium? So as I said before, the sound is produced by the vibration of the nearby molecules. So in solid medium, the molecules they are closely packed and that's why the vibration travels faster and the sound is produced for more. So the real life example is when you place your ear on the railway track or just when you place your ear on the table and just tap on it, you can feel the vibration. So this would be the best example. And the next one is reflection of sound. So here, the dolphins and whales, so they communicate the underwater communication. So they communicate each other by providing a certain kind of vibration, so which can be sensed by the other dolphins. So similarly, the bats they also provide some vibration, so which is the echo. And the next one is refraction of sound. So it is just the bending of sound waves due to a change in the medium or temperature. So, as we all know, we can hear the sound more clear than in day. So, we can hear more sound in night. So, this would be the best example. And the next one is interference of sound. So, interference means when two sound waves they meet, they cancel each other. So, the real life example is when you place two speakers playing the same music, you can hear more louder sound. That's because of the constructive interference. And the next one is Doppler effect. So it is a change in the frequency and pitch of a sound when the source moves relative to an observer. So the real life example is the ambulance sirens. So the sound differs when it approaches to you and the siren when it moves away from you. So that is an example for the Doppler effect. And the next one is light. So as I said before, the light it is a form of electromagnetic radiation and it is the nature of the light is a transverse wave. So electromagnetic radiation means which does not require any medium, so it can travel through vacuum, and the nature is the transverse waves. So these are the key properties of the light. The first one is reflection of light. So the real life example is we see our image in a mirror, so it is because of the reflection. So the principle behind that is when light strikes a smooth surface, it bounces back. And the next one is refraction of light. So it is the just the bending of light as it passes from one medium to another medium due to the change in the speed. So the real life example is when you place the pencil inside a water, it appears that as if the pencil bent. So it is due to the refraction. And the next one is dispersion of light. So it is the splitting of white light into the seven colors when it passes through prism. So we have experienced this in our laboratories, our experiments. And another example is during rainy days you can see the rainbow, so it is because of the dispersion. And the next one is diffraction of light. So it is the bending of lights around the small obstacles or edges. The example for this is the patterns on the butterfly wings and series. And the next one is interference of light. So here, when two light waves they overlap, they combine constructively and destructively. So the best example is the oil. When the oil spills on the floor, you can see the interference. And in soap bubbles, you can see the rainbow colors. So these are the key difference of the light and sound. So this I have already mentioned. So um, thank you.